All right. Hello, everybody. My name is Novotny. I'm a cloud engineer here for Oracle. I specialize in analytics and machine learning, and I'm excited to talk to you today about the relevance of retrieval augmented generation to the future success of large language models. So let's go ahead and dive into our agenda for this talk. I'm going to start by recapping some current issues that large language models are facing that are slowing their growth today. Then we'll do a deep dive into RAG, talk about the benefits of RAG and why it's so important, and then talk specifically about RAG in the enterprise, because that is where some of the best value of this technology can be gained. So we all know that there are lofty expectations for the future of large language models. In a report last year, McKinsey estimated that up to $4.4 trillion could be added to the global economy every year from large language models. For reference, the GDP of the UK was $3.1 trillion in 2021. So we're talking about a massive amount of money. Additionally, you'll see big fat claims like it can automate 60 to 70% of tasks that employees do today. So we all know that there are huge expectations for large language models. They haven't quite met those yet, largely just because it's a new technology. It's 2 years old. But there's also a number of roadblocks that are slowing its adoption in some key use cases, some key industries. So what are those? First and foremost, we have hallucinations. I'm sure you're all familiar with this. Show of hands, how many people have had a model hallucinate when they're trying to get an answer from them? Exactly, most of you. So everybody knows what this is. Models can be untrustworthy, especially if you ask them a question outside of their key expertise. If you take a general model like ChatGPT, and you dive deep into one subject, they might give you the wrong answer. A great example of this that went viral is last year, a group of lawyers used GPT to help them write an argument in court. GPT hallucinated a number of fake court cases on which it was basing its argument, and those lawyers were fined thousands of dollars. So when you have these industries and these use cases where a wrong answer is just not acceptable, large language models are not the answer right now. You also have the fact that models are stuck in time. You train an LLM on a set of data, and it doesn't understand things that happened after that. This means that models are almost instantly outdated, become more and more so quickly. So for a number of questions, they won't know the answer. The world moves fast. Funnily enough, if you ask a lot of models about generative AI, they might not know the answer because it's such a new concept. A great way to trick models is with a term like lang chain, very new, also semantically similar to blockchain. So they might tell you they don't know the answer, but they also might hallucinate if you ask them about something like that. So the fact that they're stuck in time and so expensive to retrain is a big issue. With many other machine learning frameworks, you can constantly retrain your models. As we know, that's not the case with large language models. We also have the issue of enterprise context awareness. So to gain the most value from large language models, businesses need to be able to supply them with an understanding of their business. This can be hard to do in practice. You can give small amounts of context to a model directly in a chat interface, but you can't supply much information doing that. You can train a custom model, but that's very expensive. Most businesses cannot do that, can't afford it. And then that model will still become outdated, could still hallucinate if you don't give it the right amount of information. And finally, we have accountability and safety. So as you know, LLMs give you a response and they present it as the truth. There's no understanding of how they got that answer. So when it comes to accountability for the answers they give in AI safety, there's basically nothing in place right now. So if a model hallucinates, if it presents bias, we can't really say why it did that. And that's a big issue. It contributes a lot to a lack of trust in the space that the public has. So these are some of the issues LLMs are facing today. Let's keep those in mind as we start to talk about RAG and eventually how RAG can fix these issues. So retrieval augmented generation. This is a concept based largely on a 2020 paper from a group of meta AI researchers. The original logic behind it has been around since about the 70s. But most systems in place today are based on this paper. And it's a really simple concept at its core. We're just looking to enhance the accuracy, the power of a large language model by supplying it with data from some external source. And this could come from a variety of areas. The internet is a really popular option, but we could be talking about structured or unstructured data, a small data set, or a giant enterprise data warehouse. it doesn't matter. As long as you're giving some extra context to that model, we're talking about RAG. And on the right here, we have what is probably the most simple diagram of RAG you could have. And we can walk through the steps here to understand how this differs from a normal large language model. So you create your prompt, right? You ask a question like, what's the weather in Austin today? And instead of going directly to our LLM to get that answer, a query is created from that prompt to search our knowledge source for relevant information. What that query looks like depends on the nature of the knowledge source. If we're talking about the internet, it might look like a Google search really, and then scraping those results for information. If we're talking about structured data and a relational data source, it could be a SQL query. Whatever it is, we search that knowledge source and we get some relevant information. Then the prompt, the query, and that extra information is sent to a large language model to give you a response that it might not be able to otherwise. Again, if you ask most models what the weather in Austin is today, without any help, they won't know that answer. They finished training in the past, but with RAG, they can tell you that answer. If you'd like to play with this today, I suggest you would cohere and use their Coral model. It's a RAG model enabled with surfing the internet. So you could ask it a question like what NBA teams are playing tonight. It would give you that natural language response, but also a citation of web sources that it used to help inform that response. So let's look at an example of this. Now, I work for Oracle, so I had to use some Oracle examples here. Oracle is currently in our beta release of our OCI generative AI agents. In this case, agents act as a device to search enterprise data sources for additional context. Down the right, we see what interacting with a RAG-enabled large language model might look like. So near the top left of this image, we can see that this model is connected to a Vision Corp database. And our user can ask questions like, what conversations have we had with Vision Corp related to our products? It can give that natural language answer, as well as citations as to the data it pulled from this data source to help inform those answers. So instead of this user searching through a bunch of documents to understand what their current situation is with this client, they can understand that instantly with the help of this RAG-enabled LLM. Then they can ask a really complex question. They're looking to put together a certain POC. You want to understand what products are involved, and that model can tell them that because it has this business context from this data source, and it also gives a pricing estimate. So these are some simple queries, but this is tasks that could take this worker a couple hours to do without a RAG-enabled LLM, but with it, a couple seconds. So we understand what RAG is. Let's talk about the benefits of RAG and how it can fix some of those issues that we just talked about with large language models. And if you take anything from this presentation, I think it should be this slide. This really lays out the argument for why RAG is so important. We have some of these key challenges on the left, again, starting with hallucinations. And RAG can mitigate this by grounding your responses in real enterprise data. As long as you're asking a question relevant to what's sitting in that data source, you can be confident that the answer is correct. And you can prove that because you can use the citations to look back at that data to understand what the model used to inform its answer. This is huge for mitigating an enormous problem that we saw that almost everybody in this room has had before. So it's a massive benefit of RAG. And then the fact that models are frozen in time. RAG can bring up-to-date data to models. As up-to-date as that data sources that you're querying is as up-to-date as that model can be. So if you have sales data that's rolling into a database constantly, you can constantly ask an LLM questions about that data, and it will have all the information that that data store has. This is very different than dealing with LLMs that finished training a year ago. You can't ask them any recent questions, and you can train custom large language models to understand your business. But if that business data is constantly changing, like sales data, like data about your clients, then it'll be quickly out of date, and it's expensive to retrain that model. You can't be constantly doing that. So again, just an enormous benefit. You also have the fact that your general models lack domain expertise. This can go back to our example with those lawyers. If you take ChatGPT, you can answer a variety of questions, but if you dig super deep, do a bunch of questions about US law, they might hallucinate. It's not an expert in that subject. But with RAG, you can make a model an expert in any subject. If you point it to data that has know a bunch of relevant court cases, then it can be an expert lawyer. If you point it towards medical information, it can talk like a doctor. If you point it towards your enterprise information, it understands your business. Whatever context you give it, a general model can do it. So RAG is kind of like a superpower for your general models. You can make them an expert in any area as long as they're looking at the right data. We come back to the fact with AI safety and the fact that large language models are opaque. We don't know how they get their answers. But RAG, it does give us a source of accountability with those citations I mentioned earlier. You have some information about how the model got the answer it got. This is huge, again, in a space where there's no form of accountability for large language models. We have no understanding of why they give their answers. If the answer looks fishy from a RAG-enabled LLM, you can look at those citations, understand the data it used to answer that question, see maybe that data is incorrect, you can deal with that issue, or maybe you were wrong and the data is correct, the large language model is acting as it should. And I mentioned this a little bit earlier, but organizations don't want to develop their own models. RAG can again give those domain expertise to a general model, so that is not required for your medium, small size businesses. So these are the general benefits of RAG, right? But I mentioned earlier that I want to talk about RAG and the enterprise, because this is where the real massive gains can be had from this technology. So with RAG, we can enable LLMs to access data that foundational models are not trained on, right? Your private company data that you don't want to give to a third-party company like OpenAI to have. And there's a lot of large language model use cases that companies are using a lot right now that don't require enterprise, like writing an email, fixing the tone of some text, or generating code with open source libraries. I know I do that type of thing every day at work. I'm sure a lot of you do. And that doesn't require any enterprise context. And it's useful. That's helpful. But those aren't the use cases that are going to transform the way people work, that are going to, eliminate 60 to 70% of the tasks that people have to do every day. That comes with the use cases that require enterprise context, that require the model to understand your business, understand your sales data, understand your clients. So you can ask those questions that require that context, aggregate large amounts of information across documents, give you that enterprise contextual decision making. So RAG can really enable enterprises to do these use cases that they're not right now. Large language models promise a lot of these use cases that require this information, but again, it's very difficult for companies to actually act on them because it can be so hard to supply this enterprise context without RAG. So we have a variation of the diagram we looked at previously, what a RAG architecture might look like in the enterprise. So in this case, a little work is required before a user can actually query and get this additional information. We start with our enterprise knowledge base up on the top left there. Again, whatever type of data it might be, say it's some documents, and we'll pull that information from the data store and put it through an embedding model. Turn this natural language into multidimensional numeric representations of the semantic value of that information. Once it goes through that embedding model, we can put it into a vector database. And the vector database is very important because of the speed that allows of searching over this data. You can build very powerful indexes, search over massive amounts of data very quickly. Again, this is very important when we're talking about enterprise scale. You could be talking about billions of records, and you need your answer fast, right? We're not going to sit for minutes and wait for an LLM answer. We need it right now. So with a vector database, we can search over those billions of records and get that context quickly. So once we have ran our information through the embedding model, put it in the vector database, we can now query our LLM. Our user can ask a question, maybe want to aggregate some information about a client in our company. They've been there for years. There's lots of information strewn around the enterprise about them. We want to aggregate that into a report. So we create that query. It also goes through the embedding model to turn it into a numeric representation of the semantic value of that query. And then we compare it to records in the vector database. And we're looking for something called the Euclidean norm between the values in the vector database and that query. just comparing these numeric values to understand what is semantically similar between the query and things in the vector database to tell us which context will be useful. And at that point, we get that context, and the context as well as the prompt and the query are sent to the LLM, and they are able to answer that question for us. Are there any questions at this point? Questions about this architecture? Yes.
Well, not specifically, well, maybe about, so the example that you showed before, and I don't know if you can go back to it, but it was very interesting because the question was, you know, what would a client need to create a call center analysis tool? And then the LLM analyzed the question and gave back the response of that they would need this, and this, all of the components for each of the tasks that would take, right? And so right now, for example, if I ask ChatGPT, hey, I want to create an MVP for an app for doing X, Y, or Z, it can do something similar based on the data that it has been trained on. But my question here is, in this enterprise cases where I want it to be trained on my specific data, how structured does the data need to be, or what format does it need to have? Like, for example, in the data that this specific model was trained on, did it specifically say anything about call center analysis, or, you know, what was the level of logic that the model did that was not provided by the documents, by that training data?
Yeah, that is a fantastic question. You know, it's hard to say exactly what level of specificity is required to answer any given question. I'd say the form of that could be very different. If you're talking about relational data, you know, it could be linking products to a use case. But if you're talking about, yeah, call center demo, it'd probably be a document, right? You know, saying we use X, Y, and Z products for X time. I know at a company like Oracle, we have so many internal documents going over different use cases for our different products. I'll actually give an example of that later. But many enterprises might have that information sitting somewhere. So if you point it to that right source, you know, they could find that old document that talks about how these three products could be great for this demo in this industry. So it's difficult to say exactly, but I think that data does exist in a lot of enterprises. Yes.
You mentioned that if the answer cannot be found on LLM, it can go to a different source like internet, right?
Yes.
So when that happens, the data retrieved from the internet will be added to LLM automatic, or you'll be just reference to outside the source?
It would be a reference. It's essentially like included in the prompt sent to the model. So it's like you ask the question what the weather is, right? But the LLM wouldn't just see what the weather is. They'd see that question and then, you know, this source said the weather is 70 degrees today. So if the LLM, you know, is keeping track of the questions asked, you know, then it will have access to that data in that form, but it's essentially added to the query sent to the LLM. Does that make sense?
Yes.
Is that your question?
Yes, the weather is it's easy, but if it is a document on the internet that you found like working doctor search whatever, that will be the source may change or something. How the reg you deal with that? If that is a document change outside of the source, that way.
You're asking if like the internet document is changing over time, how does it deal with that? Well, you'd be doing a fresh search every time you query it. So it would, whatever that changes to is what it would get next time, right? Okay, thank you. Yes, Boucher.
Do you see this having any impact on latency in the ultimate during generation?
Certainly negative. The hope would be that would be very small, right? And again, it totally depends on the type of RAG you're doing. You know, your speed to search the internet is totally different than your speed to search a vector database, right? So I expect this to have a small negative impact on latency. And if that impact ends up being too big, that might be an issue that has to be addressed. In the back, yeah.
All right. So I'm going to do RAG over a graph database.
Okay.
Right now I'm using Neo4j. So does Oracle have a graph database solution that I can RAG?
would say right now, no. Our RAG agents are in beta right now, so I'm not in any liberty to, talk about functionality that's gonna be in the future, unfortunately. I would say, be patient and, keep your eye on what we release. That could certainly be something in the future, but I can't say that right now. Yes, sir.
Can you walk through an example of retrieving documents? I think that step is a little bit abstract.
Yeah, retrieving the documents. There's a number of different ways you could do this. You see this references LangChain, right? Which is a Python library, a framework for accessing different types of data. And I don't have a code example or anything on me, but yeah, I would look more into LangChain. That's the leading framework when it comes to accessing different data sources to enable RAG. I don't have an example off the top of my head though, fortunately.
But your example would maybe be connecting to an existing database with an existing data set for a specific user, and then feeding that in instead of hypothetically hypothesizing what that data might look like.
Exactly. Yes, exactly. Yeah, getting that ground truth, that real data instead of the model hypothesizing what it would be exactly.
Are there any other, sorry, are there
Go ahead.
other looser types of retrieval that are done? When they basically, there's like search by similarity. Is that how the space within
Like, as far as I know, it's only semantic search. There's nothing like a keyword search being done here. Again, because it's similar to how large language models work. They work with the semantic value of data, so you're essentially doing that same approach when you're looking for the additional context. Yes. Could you say that again?
How would this architecture change if we replace large language model by a specific small language model, like focused on certain domains?
Like a domain similar to the data you're pulling?
Yeah, I mean, there are small language models.
Yeah.
Right? If we just have that by the generic model.
Yeah, I think that's certainly something you can apply in the same way. Again, you'd just be improving the question answering ability of that small language model the same way you did with a large language model. Yes.
Have a solution which we develop using which talks to the databases, which queries CSV selections, and which also does the technology features that we just discussed.
Right.
So we have the logically have to use all these elements. Is it compatible directly? Switch?
It seems like if you could take that exact architecture and then, yeah, just send the result to one of our LLMs instead of OpenAI, I don't see why that wouldn't be possible. Yeah.
And is it easy to present?
You say that again?
Is it relatively easy to present? Is there documentation that you can find? I can use the operates.
I can talk to you afterwards about that. Yeah, sounds good. Yes.
How would you test this sequence? Is it more of like trial and error from the user perspective, or how does testing get?
That's a great question that I'm not too sure about. I would assume that would come from querying and then viewing what context was returned, right? And just trying to understand if that is proper, right? Yeah, I don't have much information about testing this framework. That's a great question though.
Does Oracle Cloud Infrastructure have agents that rank the response in an artificial intelligence instead of a human feedback?
So I do know our current architecture for RAG agents does include a re-ranker. Yes, but again, this is still in beta, so I can't really say what we really do have for the public right now. Yes.
So to what extent do context size limits constrain use of this technique?
Context size limits as far as like how much additional context you're able to pull in. That is a great question. I think that would be up to the business and, how many characters you want to be able to supply to the model, right? How expensive you want every query to be. But I can't really say much about what that upper limit would be. We'll do one more question and then I'll keep moving here. Yes.
question, but someone asked about testing and if they're building out this solution using LangChain. LangChain announced a few months ago something like LangSmith that can be used for testing and debugging. So whoever asked that question, look into LangSmith. It's by the same team that designed LangChain.
Awesome, thank you. All right, so we will keep moving on here. So I have an example here, another Oracle example, of course. But we are already using RAG in our enterprise. And we have something called My Oracle Search here. You can search for internal documents, anything from like customer intelligence, competitive advantages, to HR and IT questions, right? And Oracle has so many internal sites and so many documents, it can be difficult to find the right one sometimes. I know I've experienced this. A really simple question, and it's hard to find the right link to get this done. So we augmented My Oracle Search with OCI generative AI and RAG so that we can get natural language responses instead of just like a Google search response. So we get those natural language responses directly underneath. So in this case, this person is trying to reset their VPN password, and they get a step-by-step guide on how to do so, as well as the URL to the source that informed how to do that. This seems really simple, right? But we found that up to 30% of our common IT tickets were people asking how to do these really simple tasks. So we can free up our IT by getting rid of that 30% of tickets, allowing them to focus on the real complex issues that we have. So this is something that Oracle is implementing internally. We think it's really impactful for us as well as our clients. So talking about RAG use cases by industry, we have a number of them here. We can talk to a few of these. So customer experience for insurance, creating an intelligent chatbot to manage things like accounts, claims. Chatbots are already quite popular. I'm sure you've all interacted with them. They're pretty good at answering maybe 9, 10 questions, but once you get outside of that, they don't know what they're doing. I know I many times have played around with the chatbot and just ended up sitting on hold waiting for a real person. But with RAG, we could improve these chatbots, give them access to more information about those accounts, about those claims, so that they can better answer questions and then allow people to answer again those really hard situations, bring up their time. Or we could look at banking back office, aggregating information across many reports. Again, maybe you have a client that you're trying to understand the context of more. You can aggregate their information with a simple query instead of spending hours reading through different reports to really understand their business situation. Another great use of RAG. And you might notice that a lot of these use cases are similar to use cases that are presented for normal LLMs, for non-RAG enabled ones. And a lot of them are very similar, but RAG can just do them better, essentially. So again, you can better supply that context so that your worker gets the correct responses when they're asking about this client history. You could create a custom model and supply it with all the information about your clients and ask that about your client history. And that could be very good at doing that, but it would quickly become outdated as your clients change, as they inevitably would. So a lot of these use cases are similar to those promised with regular LLMs, but RAG is better at actually implementing them and making them realistic for businesses because they're cost effective, because they actually get that real-time information. Yes. Mhm. That is a wonderful question. And
Could
that,
you repeat the question, please?
yes, yes. How do you put up guardrails as to how you're accessing that data source? That's a great question, and that all depends on the implementation of that mechanism to access the data, right? So you could implement some level of obfuscation, maybe put the data you want this RAG agent to access in a separate data store that might be different than the data store that houses some of that more sensitive information, right? That PII. So it's certainly possible, right? The LLM just doesn't have reign over all of the company information. I think I've been saying throughout this presentation, like the LLM takes the data or accesses it, but it really doesn't. You have some mechanism, like an agent, for example, that pulls that information and gives it to the model. According to the model, it's just getting some information, it's getting a prompt. There's an external mechanism that's supplying that extra context to it. So I hope that answers your question.
So if I understand correctly, this agent, sorry, it's making a search and it's retrieving the information just in that moment, but it's not retraining the model.
Yeah, it's supplying it as part of the prompt to the model, correct? No retraining happening on the model. All right. Oh, go ahead.
So as it doesn't retrain the model, so how does that like get better in the future? How does that become the large language model?
Because the data will change in the future. It'll continue to have, again, the most up-to-date context that the data store has. So as your company's data changes, it's always be pulling that up-to-date data so it can give you that good answer, whether it be now or weeks from now without any retraining required.
So does it just spit out the data or is it like?
It's not learning from the data that's pulled from the source. Yes. All right, to recap what we've covered so far, large language models poised for huge success, but they do have some issues. RAG is a great way to mitigate some of these issues, and it can enable enterprises to actually do some of the really impactful use cases that they're struggling with right now. And the faster that the hyperscalers like Oracle make RAG very easy for our customers to use, the faster that they can access these use cases. And I'm not the only one singing this song. We have a quote here from Forbes with their top generative AI predictions for 2024. You know, everybody's making their predictions right now about what's going to happen with tech in the next year. They also think that RAG is very important and that it will become much more available to enterprise customers to enable these use cases. And just to hammer home its importance one last time at the end here, these are answers from a survey of 1,000 C-level individuals for enterprise scale businesses, meaning businesses with $1 billion or more in revenue, talking about their top challenges in adopting large language models currently. And I'd like to focus on the bottom one here. This is the largest issue if you look at their 4 and 5 responses as either most important or very important. Customization and flexibility, allowing custom models to access fresh internal data. This is exactly what RAG solves, what we've been talking about today. So RAG can meet one of these issues that is top of mind for those C-suite individuals at some of the biggest companies in the United States. I think it can also help in some small ways with those other issues, but it totally fixes the bottom one. So with that, I'd like to thank you all for your time and ask if there are any final questions.
Can you maybe talk us through the complexity level that would force someone to move over to using LangChain, where right now they might be connecting directly to a database and then pulling in that data and then just using it within their prompts, where they save them as data variables and then they use them?
As far as the complexity that requires from an infrastructure perspective,
Yeah, like when would you say that people want to switch over to using RAG instead of using this situation I just described?
yeah, that would add some complexity and as to when you want to, embark on that extra step. I think that really depends on how much data you have and how much value you can extract from it. It certainly is, it adds a lot to the formula, right? To be using LangChain to do that. Something that makes sense for enterprises, which is why, I'm talking about enterprise use cases here. They have those extreme amounts of data that enable that to really make sense.
And how many sources you have. You get
Yes.
to add. If you don't, if you have one, no big deal. If you have hundreds, big deal.
And what he's asking is the progression from, what you're saying, the progression from LangChain to RAG, and that RAG can be more capable than LangChain, or?
My understanding is that LangChain is tool used to implement RAG. But one of the questions really, why would someone move from using a database, which they might already have set up on their local environment, and then just pull in that data, through functions, and then implement them using LLMs? Why typically do people want to use a RAG design system And what sort of complexity level do people start to benefit?
Yeah, and that is all about scale, and as to, if you're asking about like the exact complexity of actually doing that, I can't speak to what that actually looks like, but it is just a question of scale as to when, you make that flip.